Welcome back, dear students. So, in continuation with the previous session on importance and history of refrigeration, today we are going to discuss about the important terms in refrigeration and air conditioning. So, I hope all of you are enjoying my lectures. So, please continue watching and give your valuable comments and feedbacks in the comment section. If you are not subscribed, please do it. More helpful lessons will be uploaded frequently in various subjects under thermal engineering stream in mechanical engineering. So the important terms with respect to refrigeration and air conditioning which are commonly used throughout are the one is the performance index, that is equivalent to the efficiency in a heat engine. In refrigeration it is known as coefficient of performance, and the other one is the unit for refrigeration. So how would you specify unit for refrigeration? It is not a property, right? Usually we give unit to mass, or if it is a force, energy, all these things are having some units for examples. So refrigeration, unit for refrigeration will be given in such a way that how much effectively, or how much cooling effect, or how much heating effect a refrigeration or air conditioning device can produce per unit time. So that will be the expression of a refrigeration system capacity. So these two things will be discussed in detail in today's lecture. Okay, so we'll continue. Yeah. So ton of refrigeration, that is a unit for refrigeration or air conditioning. Tons of refrigeration. So you know a ton is 1,000 kilograms, isn't it? Ton is 1,000 kilograms. So the definition of ton of refrigeration, it is abbreviated as uppercase TR. The amount of heat or amount of thermal energy that needs to be removed from 1 ton of water. You know that when we need to convert ice to water, we need to supply heat onto it. Similarly, if you want to convert water back to ice, that is phase change process from liquid to solid, if it needs to be taken place, we need to remove heat from water, right? So that the water will get solidified. So amount of heat that needs to be removed from 1 ton of water to make ice at 0 degrees Celsius in 24 hours. So previously only ice was used as a method of refrigeration. Only ice was available, as we have seen from the history. So the historical displays, as well as the written statements, as well as pictorial representations, prove that ancient people themselves were using ice for having some cooling effect, to store perishable food items for a longer period of time, especially in warmer climates and all. We have discussed that, right? So from that only this ton of refrigeration term came into existence. ASHRAE, American Society of Heating, Refrigerating and Air Conditioning Engineers, defines 1 ton of refrigeration as equivalent to refrigeration capacity of 3.516 kilowatts, or 30 to 3.95 kilocalorie per hour. So tons of refrigeration are simply tons. We can write tons in TONNE or TON depending on whether it is American English or British English. It is often used as a general term to indicate the capacity or size of the refrigeration plant. So it is joules per second. How much joules per second? How much energy a refrigeration unit can remove per second? So watts, 3.516 kilowatts, that is equivalent to 1 ton of refrigeration. That means the refrigeration system, if it is designated as 1 TR, means it is able to remove 3.516 kilojoules of energy in the form of heat per second from the space to be cooled. Okay. So it is in British units, it is equivalent to 12,000 BTU per hour. 12,000 BTU per hour. It is the amount of heat required to melt 1 ton of ice in 24 hours. This is another way of defining in terms of British thermal unit. So a refrigeration ton is approximately equivalent to 12,000 BTU per hour or 3.5 kilowatts. So you need to remember 1 TR is equal to 3.5 kilowatts approximately. 3.5 kilowatts. Fine. Now, before defining and understanding the second important term, that is the coefficient of performance, let us have a look at the difference between refrigerator and a heat pump. Both are functioning in the same way except the desired effect. In a refrigeration system, the desired effect is maintaining lower temperature. On the other hand, in a heat pump, the desired effect is maintaining a higher temperature than that of the surroundings. Both the devices, while receiving external supply of energy, transferring heat from a low temperature reservoir to high temperature reservoir, whether it is refrigerator or a heat pump. But the effect is different. Refrigerator is meant for maintaining a lower temperature, but the heat pump is meant for maintaining a higher temperature. That's the only difference. Now, let us define COP or coefficient of performance. It is a parameter equivalent to efficiency of heat engines, as I mentioned earlier. So you know what thermal efficiency is in a heat engine. You may have studied in thermodynamics. So COP is the amount of cooling or heating effect. It is cooling effect in refrigeration system and heating effect in heat pump. So cooling or heating effect produced by the given refrigeration unit or a system for a given work input. So we are giving certain work input. So for the given work input, how much effect, desired effect, a refrigeration unit can produce, that is given by coefficient of performance. So mathematically we can express COP of a refrigerator or a heat pump as desired effect by work input. Commonly it is written as refrigerator, whether it is heat pump or refrigerator. Commonly we used to write like this because the same system can function as a heat pump or a refrigerator. So heat pump, it is the highest temperature, how much thermal energy it can deliver to the high temperature reservoir matters, and in a refrigeration system how much energy a system refrigeration unit can absorb from the space to be cooled, QL, that is the amount of energy absorbed from the low temperature reservoir, that is QL. On the other hand, on a heat pump it is how much energy is rejected to the high temperature reservoir. So QL by WN. WN is the work input. So we can write in terms of QH and QL. If you recollect the first law of thermodynamics, in a cyclic process, delta W is equal to delta Q. Please recollect. So similarly, we can write for COPHP as QH by QH minus QL. Now we can prove that always the COP of a heat pump is greater than unity. And it is related, COP of a refrigerator and heat pump are related like this. COP of HP is equal to 1 plus COP of refrigerator. So it's an assignment for you. Please prove this from the discussions what we have so far, and submit as an assignment in the classroom. If you have any questions with respect to today's class, please use the comment box below. Thank you. We will meet with another interesting session in the next class.